Hello everyone, welcome back to my channel NCRT Maths with Bardeep. Today we are continuing our chapter number 3, that is pair of linear equations in two variables of grade 10. So today's topic is graphical method of solution of a pair of linear equation. As I have already explained in my previous video that whenever you will draw a graph of your pair of linear equations, there will be three different possibilities. That is, both lines will be intersecting lines, they will be parallel lines, or they will be coincident lines. So what is the terminology related to these things? If we have any solution, that is whether we have only one solution or infinite solution, that category is referred as consistent pair of solution. A pair of linear equation which has one solution, that means if they are intersecting lines, then that pair is called consistent pair of linear equation. Second possibility is if the pair of linear equation has no solution, the graph is a set of parallel lines, then we can say that particular pair of linear equation is referred as inconsistent pair of linear equation. And the third category is if the pair of linear equation has infinitely many solutions, that means they are in the third category, coincident line, then that pair will be referred as dependent pair as well as consistent pair. In your examination, or we can see in the different questions of your exercise also, sometimes they will ask, first check whether the given pair is consistent or inconsistent. If consistent, then find the solution. So this means first we will check whether they have any one solution or they have infinite solution, then only we can tell that that pair of equation is consistent pair. If we have no solution, then that pair will be referred as inconsistent. So how to identify whether the given pair is consistent or inconsistent without even solving? We can do it in this way. In a generalized form, we know that any one equation is ax plus by plus c equals to 0. But now we need to consider a pair of linear equation. So the general format is a1x plus b1y plus c1 equals to 0 as my one equation. a2x plus b2y plus c2 equals to 0 as second linear equation. And as we already know, a1, b1, c1, a2, b2, c2 are all real numbers, plus square root of a1 square plus b1 square should not be 0, or itself we can write a1 square plus b1 square should not be equal to 0. Similarly, a2 square plus b2 square should not be equal to 0. That means we have a pair of linear equation in two variables. If they are intersecting lines, that means they have one solution, then definitely their a1 by a2 should not be equal to b1 by b2. If they are coincident lines, then a1 by a2 should be equal to b1 by b2 should be equal to c1 by c2. And if they are parallel lines, then a1 by a2 equals to b1 by b2 should not be equal to c1 by c2. So what is the meaning of this? That means any pair is given to us, we will recognize this a1, b1, c1, a2, b2, c2. Okay, make sure that right hand side is always 0. Sometimes the equation will be given as 3x plus 4y equals to 5. So we will not consider this as c1. We will first shift this to other side. So plus 5 will become minus 5 and right hand side should always be 0 if you want to use this interpretation. Okay. So then this is a1, this is b1, this is c1. Similarly, for second equation, we will find a2, b2 and c2. Okay. And then we will find a1 by a2, b1 by b2 and c1 by c2. Right. After finding these three values, we will check whether a1 by a2 is not equal to b1 by b2. Then directly we can say that they are intersecting lines. Okay. But if all fractions are equal, that means a1 by a2, b1 by b2 and c1 by c2 all are having same values, then we can say that they are coincident lines. And thirdly, if two values are same but third one is not same, a1 by a2 is equal to b1 by b2 but it's not equal to c1 by c2, then we can say that the graph will be parallel lines. So this is very helpful in finding the solution. No need to find the solution straight away, but before that we should check these values. Okay, if this possibility is there, that is 1, so we can say that it will have one solution because lines are intersecting. So what we call that, any pair of equation which has one solution, consistent pair. Okay, second is if all the ratios are same, then they are coincident line. Coincident line means they have infinitely many solutions. But if a1 by a2 is equal to b1 by b2 but not equals to c1 by c2, then we can say that this pair of linear equation has no solution or inconsistent pair. Sometimes 1 mark question will come, check whether this is a consistent or inconsistent pair. If any one of them is true, then we will say it is a consistent pair. If this is for true, then we will say this is not a consistent or inconsistent pair of equation. Sometimes they will ask you, tell whether this is intersecting line, parallel line or coincident line. Again we will find these ratios and see which condition is true, and accordingly we can identify them as these three categories. So I hope now you can identify whether the given pair is consistent or inconsistent. So let's take an example to make it more clear. So let's take an example. Check graphically whether the pair of equations, so this pair is given to us, is consistent or not. If so, solve them graphically. That means first we should check whether it is consistent pair or not. If it is consistent, only then you should draw graph to find the solution of this pair. So let's write the equations. So one is x plus 3y equals to 6. As I have already mentioned, whenever you have to check, this right hand side should be equal to 0. So we will shift this 6 to left hand side, that is x plus 3y minus 6 equals to 0. So this is my first equation. Second is 2x minus 3y equals to 12. So again make right hand side equals to 0. So minus 12 equal to 0. So now let's find what is the value of a1, a2, b1, b2 and c1, c2. So here a1 equals to a2 equals to b1 and b2, c1 and c2. So what is a1? Coefficient of x. So this is 1 and a2 is 2. Okay. So coefficient of y, this is 3 and minus 3. First one is positive 3, second is minus 3. C1 is minus 6 and C2 is minus 12. After finding these values, we will check what is the value of a1 by a2, b1 by b2 and c1 by c2. So here a1 over a2 is equal to 1 by 2. And what is b1 by b2? So this is 3 over minus 3. If you simplify them, this is minus 1. And then is c1 by c2. This is minus 6 over minus 12. So minus minus will be cancelled. So this is plus 1 by 2. Okay. So now we will check our three cases whether a1 by a2 is equal to b1 by b2. So here 1 by 2 is equal to minus 1. No. So first condition itself is true. That is a1 by a2 we can find since 1 by 2 is not equals to minus 1, or you can write a1 by a2 itself is not equal to b1 by b2. So what were the three cases? First was a1 by a2 is not equal to b1 by b2. then it will be a consistent pair. So our condition is true here only. So we can say that yes, they are a consistent pair of linear equation. If first two are equal, then we will check the third value, that is C1 by C2. If all are equal, then again it will be a consistent pair because it will have infinite solution. But if first two are equal but third is not equal, that means A1 by A2 is equal to B1 by B2 but not equals to C1 by C2, then we can say that the equation will have no solution or inconsistent pair. So our question was, if they are consistent, solve them graphically. So here we can see that since this condition holds, so this is a consistent pair. So now let's see how to solve them graphically. So first thing is, we will make a table for each equation that you already know how to make. Let it be x, y, and any 2 or 3 points you can find out. So first equation is x plus 3y equals to 6. So put x as 0, then 3y equals to 6. And what is the value of y in our case then? 6 by 3 as 2. So the first point is 0 and 2. Okay. So next, let's put x as 3. Why I am putting x as 3? See, if we put x as 1, then this 1 will be on this side. 6 minus 1 is 5 and y will be 5 by 3. So 5 by 3 is difficult to plot on graph paper, so better to ignore that value. Okay. We need randomly any 2, 3 values. So now if x is 2, then also 6 minus 2 is 4. So we need to plot 4 by 3. Why to take this tension? So better to put only those values which will give us those numbers which are without decimal. So if we put x as 3, then see 3 plus 3y equals to 6. So what is 3y then? 6 minus 3, this is 3. And what is y? 3 by 3 as 1. Okay. So if x is 3, y is 1. Similarly, put x as 6. Then it will be 6 plus 3y equals to 6. This will be shifted to other side. So 6 minus 6 is 0. So y is also 0. Okay. So third point is 6 and 0. So these 3 points are enough. So let's make a table for second equation. This is second equation is 2x minus 3y equals to 12. So let us suppose x as 0 first. Then it is 0 minus 3y equals to 12. So what is the value of y then? 12 over minus 3. This is minus 4. So if x is 0, y is minus 4. Okay. So now see again, I need a multiple of 3. If I put 1, so this is 12 minus 2 is 10. 10 by 3 is not a whole number. So I can put 2 here. So 2 into 2 is 4. 12 minus 4 is 8. Again 8 is not divisible by 3. Let's take 3 here. So 3, 2 into 3 is 6. 12 minus 6 is 6. 6 over minus 3 is minus 2. So if we put x as 3, we will get minus 2. I can solve here also. Put x as 3. So 6 minus 3y equals to 12. And minus 3y is 12 minus 6 as 6. So what is y then? Minus 2. Okay. Similarly, if you put 4, that number is 8. 12 minus 8 is again 4. Not come in the table of 3. Then we can put here 5. This is 2 into 5 as 10. So here not possible. 2 into 6 as 12. So 12 minus 12 is 0. So we can put x as 0. So this is 12 minus 3y equals to 12. So minus 3y is 12 minus 12 as 0. So y is 0. if I put x as 6, y is 0. So this is how we will make these tables first in order to draw a graph. Okay, so now let's see how to make a graph on the basis of these tables. So now let's plot the graph. See, in this table I can see that x values are from 0 to 6 that I have chosen, and y is maximum positive value is 2 and negative is -4. So I have marked these points accordingly. One thing you can identify directly is, so this is the common point in both tables. If you are lucky, you will definitely get this point itself in the table. So that common point which is in the both tables is a solution of your linear pair. Or we can say that this common point is the intersecting point of your graph. Okay. But sometimes we are not able to find a common point. Then what we will do is we will draw the lines and then extend them further and see where they will intersect. Let's first plot this. This is 0 and 2. So this point. Second is 3 and 1. This thing. And 6 and 0. Okay. So these 3 points. So we will name this equation as x plus. So this is the main thing, that after drawing a line, you should always mention that this straight line belongs to which equation. So let's see the second one. 0 as -4 means this point. Then 3 as -2. So somewhere here. And 6 and 0. So this point. So again, like this. Okay. So we will mention the equation for this line, that is 2x minus 3y equals to 12. Till here, what I have done, I have made the table, plotted them in the graph, and these two lines are there. Okay. So what is the solution of this pair according to the graph? Because our point is solve them graphically. So what is the solution? The intersection point of these straight lines. So this is the intersection point. What is this point? That is 6, 0. Okay. So what is the solution? This is the solution. We will say that therefore 6, 0 is the solution of these pair of linear equations. I hope this is clear. How to find the solution of a pair of linear equations graphically. First, you should check whether they are consistent pair or not. If they are consistent, only go to next step. Otherwise, directly you can write it here. This pair of equation is inconsistent. If it is consistent, make the tables by putting randomly 2-3 different values and then plot these tables on your graph paper. The intersection point or the common point of both lines will be the solution of your pair of linear equations. I hope this topic is clear to you. This is all about this video. See you in my next video with the further topics of this chapter. Thank you.